Hello everyone, this is N.K. Sagar, uh, working in the Department of Mechanical Engineering, Sagar Institute of Research and Technology, Bhopal. So welcome you all in today's session. In today's session, we are going to discuss about the mechanical properties of the materials. And this lecture will be especially beneficial for the students studying in the third semester under the University RGP Bhopal. So let us start today's session with the mechanical properties. Yes, all of you know about these mechanical properties, and already you have studied many times about the mechanical properties. So these are the different mechanical properties like strength, elasticity, stiffness, flexibility, plasticity, ductility, malleability, toughness, resilience, hardness, brittleness, creep, fatigue, and malleability. And these all properties are important because in the uh, in university examinations, one or two questions are framed on the basis of these properties. So one by one, we discuss about these properties. Yes. So mechanical properties of the materials. So what are the mechanical properties of the materials? These are the physical properties that a material exhibits upon the application of forces. And actually, the mechanical properties of the materials gives the information regarding the behavior of the materials during the application of load. When external load will be applied on the material, then how the material will behave. So this is the behavior of the material is decided by the properties of that material. So this is the property that is known as strength. What is strength of the material? Strength means this is the resistance offered by a material during the application of external force. This is called strength of the material without failure. It is the ability, in another way we can also define it. This is the ability of the material to sustain or bear the loads or stresses without distortion or failure. This is known as the strength of the material. And the strength can be tensile strength, compressive strength, shear strength, bending strength, and torsional strength. And how these strengths are calculated with the help of machine tools like universal testing machines. The different strengths of the materials can be calculated like tensile strength, compressive strength, and bending strength. As now, the second property is hardness. Hardness is also the property of the material. It shows the resistance offered by the material towards the mechanical indentation, and it is the general indication for the strength as well as resistance to wear and stretching. Then another way we can define the hardness. The hardness is the ability that resists plastic deformation during the application of load. And we know that diamond is the hardest non-material in the uh, materials, and brittle materials are more hard. It is preferred mostly for components that slide over one another. Actually, hardness mostly preferred for those components that slide over one another, and also preferred the hardness for the all cutting tools, so that they can cut the other materials without wearing away rapidly. And how is it measured? Is it measured with the help of testing machines known as Brinell hardness testing machine, Rockwell hardness test machines, and Vickers hardness test machines. With the help of these testing machines, we can measure the hardness of the materials. Yes, toughness. The next property is known as toughness. Toughness is the property that can be defined that as it is the ability of material to withstand suddenly applied load and thus absorb a certain amount of energy without failure. And in the stress strain diagram, all we have seen that the area under the stress strain curve is also known as toughness. And mathematically, it is expressed as energy upon volume, that is in joule meter per cube. And it depends both on strength and ductility. The property toughness depends upon the both strength and ductility. Alloy steels with good toughness are used for manufacturing of cutting tools like milling cutters for the gears. Yes, the gears are cut by the milling cutters, and these cutters, for those cutters, the toughness property is referred subjected to the impact loads. How the toughness is measured? So there are some tests known as Charpy test and ISO test. So with the help of these tests, we can measure the toughness property of the material. After toughness, ductility. So ductility, it is the property of material which permits permanent deformation before fracture by stress and tension. It is the extent to which a material can sustain plastic deformations under tension before fracture. And we know that the gold is the most ductile metal of all metals. And it is the measure of how much strain a material can take before fracturing. Ductility, this is the measure of how much strain a material can take before fracturing is known as the ductility. And it is expressed by the percentage elongation that is equal to change in length upon original length multiplied by 100. So by this way we can express the property ductility. In a very simple words, we can define the ductility is the property of the material uh, in which the material can be converted into the wires under the application of tensile loading. So this is the example. This is the copper material, right? And a person applies some force to pull the copper, and the material converted into the wires. So this is possible because of material is ductile. The material has property of ductility. Next property is brittleness, right? So brittleness is the inability to undergo plastic deformation. The materials that undergo very little plastic deformation without significant plastic deformation is called brittle. If the percentage of elongation is less than 5%, the material is treated as brittle. And if it is more than 5%, the material is ductile. And these are the examples of the brittle material like glass, cast iron, ceramics, wood, and concrete. All these uh, materials are brittle materials. All these materials have brittleness property. And what are the characteristics of the material that is having brittleness? They are weak in tension and stronger in compression. and these material can break without failure. With these materials can break without any tear warning because of brittleness. So thank you very much, and in the next session we will meet soon. Thank you very much.